composition of functions. The composition of functions is applying one function to the result of another function. It is written in two ways: f composition g of x, which means the same thing as f of g of x. When dealing with composition of functions, we always start with the innermost function, get the results from this function, and pass them to the outer function. So looking at problem number 1, g of f of 2. First, we look at f of 2, which gives us 4 times 2 minus 3. 4 times 2 is 8, minus 3 is 5. We apply the 5 to function g. G of 5 gives us 5 squared plus 1, which is 26. The resulting answer is 26. Now pause the video and work problem number 2. Let's check your answer. First, the innermost function is g of 2. G of 2 is 5. Next, we apply the function f to 5, which gives us 17. Did you get the correct answer? Good job. In problems 3 and 4, we see the other notation. Remember that the circle denoting composition is an open circle, not a closed dot, which means multiplication. In this notation, the first one that we apply is the one to the right. So we want to evaluate g at -3, which gives us 10. Next, we do the outermost function, f, evaluated at 10, which leaves us with 37. Now, you work problem number 4. Did you get 226 as your answer? If not, go back and check your math. With problem number 5, we are substituting not just a value, but the expression 2a. So in the function g, wherever we see x, we change it to 2a. This becomes 2a squared, remember the squared is outside the parentheses, plus 1. Then we apply this to function f. Everywhere we see an x in function f, we replace it with 2a squared plus 1, which gives us 4 times 2a squared plus 1. If you wish to expand it, this would be 4 times 4a squared plus 1. And then distributing the 4 leaves us with 16a squared plus 4. Now pause the video while you work problems 6 through 10. In this next section, we will use tables to evaluate the functions. Remember to always start with the function on the inside. First, we evaluate m at 5. So we find our function m when x value of 5 returns -1. Then we want to evaluate the function x at -1, which gives us 4. Now you try it. Pause the video and work problem number 12. If your answer is 0, you have worked the problem correctly. If not, go back and check your work. For problem number 13, remember that when using the composition dot, the first function you apply is the one to the right. So we want m evaluated at 2, which gives us 6. Then h evaluated at 6. There is no h at 6. So this function, composition, is undefined. Pause the video and practice with problems 14 and 15. If your answers are 6 and -1, great job. Now let's look at the problems, the table below. In this case, we've been asked to find k of v of x. K of v of x. Use the tables to the left to fill in this table, k of v of x. Your correct answers should be undefined, -4, 1, 6, and 11. Now, turn over to the back, and we're going to use graphs f of g and g of x to answer the questions that follow. First, we're asked to find g of f of 0. So we look at when x is 0, what is the value of f? And we find that value is 2. Now we apply g of f of 0. F of 0 was 2. Now we look at g of 2, so when x is 2, g is equal to 4. So our final answer is 4. Let's do another one. G of f of 4. When f is 4, the value is 4. So now we want g of 4. We look at the function g. When g is 4, the answer is 2. So our final answer is 2. Remember, with the composite circle, we're going to do f first and then g. F of 5 is equal to 6. So we want g of 6. G, when g is 6, the function is 2. Finally, g of f of 9. When f is 9, we get the value of, when x is 9, we get the value of f as 2. So now we want g of 2. When x is 2, the value of g is 4. So our final answer is 4. Now, pause the video and you work problems 21 through 24. Your correct answer should be 4, 0, undefined, oops, your correct answers should be 8, your correct answers should be 8, 6, 3, 6. For this last section, pause the video while you complete the table and then draw the resulting graph on the grid provided. Your resulting graph should look something like this. How does it compare to the original, y equals m of x? That's right. The new graph is a horizontal compression of the original.